Welcome back to Console Cowboys. In the last video, we did a simple replay attack, and then we took a look at what was being sent over, and we're going to try to understand it now and create a more precise attack. So on the screen, I have our capture in Audacity from the last video, and you'll notice a kind of wave pattern with peaks and valleys. There are different distances apart with the spacing. And basically those represent ones and zeros. So a peak is a 1 and a valley is a 0. So if we were to decode this, we would have to create a series of ones and zeros and send that over with our YardStick 1, but we'd have to convert that to hex. So let's do that now. If we take a look at the first peak, that would be a 1. And then the valley after it would be a 0, but then the one right after that looks like it's quite a bit wider, like it might be 3 peaks, so maybe 1, 1, 1, and the same with the valley right after that. That also looks like it would be 3 wide. So what we're looking at here is a waveform that looks like it's a combination of 3 and 1 width valleys and peaks. So if we break out a text editor, so with my text editor on the screen here, you'll notice a binary representation of what's above. Like we talked about, it starts with a 1, followed by a 0, a pattern of 3 ones, and a pattern of 3 zeros, and so on throughout the whole pattern. So I've also converted this from a long string of 1 and zeros to 8-bit bytes, so that way we can represent them in hex when we convert. And then at the very end, there is a 1. So what I'm going to do is add zeros and pad it all the way to the end to match the length of a byte. I'm not sure if this is the correct way to do this, so if it's not, please comment below. But my assumption is that we need a full byte, and after the pattern above, it looks like it's just flatline zeros. This could be completely wrong, but it seems to be working, so we'll go with it. So there are many ways to convert this binary into hex. We can do this with online tools where we can post it into a form and receive our hex back. We're going to use a tool called Radar2, which has additional tools with it that can do conversions to different representations. So we'll load that up and we'll type in rax2, and we will post in our binary with a B after each byte. And this should give us back the hex that we need. So let's post this back into our text editor and create a program to send over our hex and ring our doorbell. We can now use the hex we got from Radar2 to replay the doorbell using the YardStick 1. First we have to take all of the zeros in this and replace them with backslashes so it fits the correct format YardStick is looking for. And then once we do that, we're going to delete the rest of the stuff in this file and post in some code and use our hex to send it over. So here's the code we have. We're going to paste that where it says hex here. This is a little template you can use to send over hex with the YardStick 1. Let's save this file. We'll save it to door.py and save. The YardStick 1 uses the rfcat library, so we're going to import the rflib. If you need to know how to install this, it will show it on the blog. The first thing we need to do after importing is create an instance of rfcat and set its parameters. We're going to set the frequency, which is going to be 315 followed by 6 zeros. We'll set the modulation type to ASK, which is amplitude shift keying. We'll set the MDM rate, which is the sample rate, to 48. Inside your GQRX settings, when you set your device type, it will say 48 at the bottom. That's what we actually captured it at. And then we have to send over our hex. We do this down here, and then we times it by 40 in order to make sure that the receiver sees it in case it misses it on the first try. With this, we should be ready to send it over. If we open up our terminal You will notice that when we sent our transmission, we didn't hear the door alarm go off, and there's a reason for that. That will become clear when we actually compare the output of the YardStick 1 to the output of the original transmitter. So let's take a capture of our YardStick 1 sending a transmission, and then we will compare it to our previous transmission, and it'll become clear what's going on. Let's open up our GQRX and start listening with our RTL SDR adapter. We will pull up our terminal and set that up to send another transmission with the YardStick 1. Nothing seemed to have went across when we sent that, so let's take a look at our code. 40 may be a little too much, so let's try 10 and send that again. I see a transmission there, but the doorbell still didn't go off, so we still have an issue. Let's record the transmission with 10 and compare that to our previous output. Alright, we got that recorded. Let's pull up the file and take a look. Let's highlight the main area and zoom in. And what you'll notice is that there's far less spacing between each of the patterns, but the patterns look similar to what they were before in that they are 1 0 1 1 1 0 0 0, meaning we probably decoded things correctly, but our spacing is a lot smaller. So let's add some spacing between our patterns and see if it fixes the issue. One thing I noticed during testing is 6 hex zeros seem to work. Anything less than that didn't work, and anything more than that didn't really matter. You could add as many extra as you wanted. Let's pull up our terminal and give it another shot. Alright, perfect. It looks like we got everything working. Added a little padding and matched it up with the original transmission. If that didn't work for you, try it one more time just to make sure. If not, take a look at your code and make sure everything's right. That's all for this video. In the next video, we'll take a look at the motion sensor and figure out how to disable the motion sensor with its own functionality. If you learned something, hit the like button. If you want to keep up to date of new videos, hit the subscribe button below, and we'll see you in the next video.